Hey guys, welcome back to my channel, The Math Pad, and today we're going to do some 2D trigonometry, which is basically going to focus on Pythagoras and SOHCAHTOA. So first we need to understand how all of these concepts are applied and on which type of shapes these concepts are applied. So Pythagoras and SOHCAHTOA are applied on right angle triangles. In a right angle triangle, we obviously have one angle which is a 90-degree angle, hence the right angle. And then we have other two angles, example if it's alpha or beta. It can be any angle. So what we need to understand is that the diagonal is always the hypotenuse, and the other lengths can be either the adjacent or the opposite depending on what our base angle is. If our base angle is beta, so for example, sine beta would be, call this A, B, C. So sine beta would be AB over AC, which is basically opposite over the hypotenuse. So in case of beta, this is your opposite, and this is your adjacent, because adjacent is the line on which the angle lies. Similarly, cos beta would be adjacent over hypotenuse, which is basically your BC over AC. Adjacent over hypotenuse. Tan beta would be opposite over adjacent, which is AB over BC. So this applies the SOHCAHTOA part. If our base angle was alpha, so in the case of alpha, sine alpha would be BC over AC. Now the reason why opposite has been changed for this triangle is because your base angle is alpha, and alpha lies on the line AB. Hence the role switches. AB becomes the adjacent for alpha and BC becomes the opposite. So that's going to be BC over AC. Cos alpha would be AB over AC, and tan alpha will be BC over AC. So this was the SOHCAHTOA part. Talking about Pythagoras, Pythagoras is once again only applied on right angle triangles. And the formula for Pythagoras is a square equals to b square plus c square. Now, if we draw another right angle triangle over here, a square basically denotes your hypotenuse. B and C denote your opposite and adjacent. So since both the values are being added for b square and c square, it doesn't matter which is the adjacent or which is the opposite, but the placement of the hypotenuse is very important. So it's the hypotenuse squared equals to opposite square plus the adjacent square. That's the Pythagoras theorem, and before that we discussed SOHCAHTOA. So keeping all of this in mind, if you look at question number 1, it has given us a right angle triangle. It has given us two lengths, and it wants us to find the unknown, which is an angle. So keeping all of this in mind, we first deduce that the diagonal is always the hypotenuse, which means this is going to be our hypotenuse. And since the angle lies on this line, so the length opposite to the angle is going to be your opposite, which is this. So which means this length is your adjacent. Now we have the opposite, we have the hypotenuse, and they want us to find the angle. So now if we look at our formulas for the trig ratios, we can see that in sine, we need opposite and hypotenuse, whereas in cosine, we need adjacent and hypotenuse. If we don't have the adjacent, so automatically cosine is out of the question. Same goes for tan. Tan also requires opposite and adjacent. So once again, we can't use tan as well. So it goes back to sine. Sine x equals to opposite, which is 4, over hypotenuse, which is 7. So once we have figured out what the trig ratio is, we will just directly plug in the value in the calculator and find the value of x. So what we do is in the calculator, we do sine inverse. Sine inverse of 4 divided by 7, which gives us 34.85. So when I say sine inverse, what I mean is that when we take sine, cos, or tan from one side to the other side, on the other side becomes the inverse. So we write x equals to sine inverse of 4 divided by 7. And then we just write this in the calculator, which gives us 34.85. Correct it to decimal places. Then if we go to the next question, I'm going to keep the notes on the screen for better understanding. In question 2, it's saying from the top of a building 300 meters high, the angle of depression of a car is 52 degrees. Calculate the horizontal distance from the car to the base of the building. So obviously C represents the car, and this is your building, like the base of the building. So it says the angle of depression of a car. So that angle of depression will be over here. Now, for those of you who don't know what the angle of depression is the angle that you make when you're looking down at something. So if you're looking down at the car from the top of the building, this is going to be an angle of depression. And the opposite of angle of depression is the angle of elevation, which is when you're looking up. So that's the difference between the angle of elevation and depression. So going back to this, it wants us to calculate the horizontal distance, which is basically this. So keeping in mind, like SOHCAHTOA, we know that 300 meters is the length opposite to the angle. Hence, this will be the opposite. And since x is the length on which the angle lies, so that's going to be our adjacent. So we have the angle, we have the opposite, we have to find adjacent. So looking at our trig ratios on the side, we can see that opposite and adjacent together come only in tangent. So tan of 52 equals to 300 over x. Now, since we're trying to find the value of x, that means it needs to be made the subject in the equation. So in order to make x the subject, we swap tan 52 with x. So it becomes x equals to 300 over tan 52. Now what we do is we plug in the values in the calculator. So 300 divided by tan 52 is 234.39. 34.39 meters. Now, if you're wondering why we didn't take tan inverse in this case, the reason is that in the previous case, we were trying to find the angle, not the length of the sides of the triangle. So just keep in mind, whenever you're trying to find the value of the angle, you have to take tan inverse or cos inverse or even sine inverse, depending on what trig ratio we're using. But if you're trying to find the length of like the size of the triangle or like whatever the figure is in the question, then you don't take the inverse of the trig ratio. Okay. Then we look at the next question, which is this. Okay. In question 3, it's saying calculate the angle BAC. So since we know that the diagonal is always the hypotenuse, so let's label that first. And since it's saying calculate the angle calculate the angle BAC, so this is where the angle is. For those of you who don't know, when it says like BAC or like anything else, the angle is situated at the point where like the point which is in the middle of the letters. So in this case, since it's BAC, so A is in the middle, so that means the angle is situated at A, not at B or C. So this is the angle that we have to find. And since BA is the line on which the angle lies, that is your adjacent. So we have the hypotenuse, we have the adjacent, which means we can only use cosine. So cos of angle BAC equals 0.9 divided by 3.5. Now, once again, I told you if you're trying to find the value of the angle, we take the inverse, which means angle BAC will equal to cos inverse of 0.9 divided by 3.5. And we just plug this in the calculator. Cos inverse of 0.9 divided by 3.5 is 75.10. Correct to 2 decimal places. That is your answer. If you have any questions or confusions about either of these, just let me know in the comments below and I'll help you out.